Welcome everybody. My name is Amanda Ball and I'm a program manager with NGDU, and I'm happy to welcome Joshua Kerievsky, who's the founder of Industrial Logic, and he's going to tell you a little bit about an e-learning opportunity that we offer here at Google through Industrial Logic, and he's going to show you how you can become a programming rock star using it. So, Josh.
Thanks, Amanda. Thanks very much. Well, it's a pleasure to be back here at Google. We've been teaching workshops here in person for about 4.5 years. Over the space of that time, we've been working really hard to make e-learning that could effectively replace us. E-learning got a really bad name, I think, in the early days. More than 10 years ago, people would take PowerPoint slides and sling them up on the web and call it e-learning. And we like a challenge, and one of the challenges we've been going after is how to automate ourselves. As practitioners and programmers, we routinely teach workshops, and I think the best kind of people that teach are also hands-on programmers, because if you're not doing hands-on programming, you just don't have the goods to deliver. So we keep ourselves with our hands dirty quite a bit, but we teach a lot of these intimate 12-person workshops, let's say. And they're wonderful, but they don't scale. They do not scale. A company the size of Google needs, there's hundreds or thousands of engineers who need to learn really important design techniques. And we teach those, but we said, how can we make this be scalable? How could we replace ourselves? How could we create an experience online that would rival what we do in person? And in some cases, we even wanted to make it better than in person. How could we make an experience that would be better than in person? We're constantly pushing the boundaries to make that happen. And I think what I'd like to do today is demonstrate what we've done, so you can get a feel for the kind of e-learning that you actually already have access to here at Google. Google's NGDU department have worked closely with us to offer this to you. So this is really kind of a way for you to just get a view of what's available. So I'm going to spend probably at least half of this talk, if not more, programming live for you and uploading some of my results and seeing some of the graphs that we generate and stuff like that. So if you want, ask questions along the way. I'm happy to answer them. Let's get started. First off, I'm showing you a home page here which has numerous albums on it, okay? The main albums that we've built over the years have gone around design activities, design things like code smells. We teach code smells because we think it's important to know what bad design looks like so you can know how to produce good designs. So the whole album just devoted to code smells. Then, of course, refactoring is how do you clean up code smells? How do you improve the design of existing code? All of these are available in Java, C++. We also happen to do them in C#. Then we get into micro-testing. How do you write good unit tests? Right? Unit testing here is extremely important. It's important in companies around the world. Well, we've decided instead of starting by teaching people test-driven development, let's teach them how to write good unit tests first. And I'm going to demonstrate some exercise in there as well. And then there's test-driven development. This is the probably, in my opinion, one of the most important advances in software development easily in the last decade. It turned programming upside down in that it basically said start out by writing a failing test before you write any code and get in that cycle. We're going to see an exercise that I do in there as well. More about mock objects and fakes and stubs and all those things. We've covered a lot of the Google's own technology, so we use gtest for C++. How many of you here are C++ programmers? Okay, good. Maybe almost half. Excellent. So gtest we use, that's the only thing we use, and gmock. We also use gmock quite a bit. For Java, we're using jmock and going through all stuff like that. So we also get into legacy code. How do you deal effectively with legacy code? That's probably what most of us are dealing with, and there's a bunch of material on that. Finally, we get into design patterns. We have a 3-volume box set on design patterns. This represents about 15 years worth of work over a lot of pain in building this material with my colleague Brian Foote. So there's a lot of material here. This is part of our design patterns workshop, and we've automated a lot of this. So I'm going to jump in for a second to an example of what we're doing. First off, our operating opinion is that most people don't have any patience with anything on the web. So you've got to make this extremely compelling to keep people's attention. So our design says that every page has got to hold your attention. So for example, if I wanted to study the command pattern, okay, one of the first things I'm going to see is some image that's hopefully going to stick in my head. And actually, I'll go to full screen mode here. And here's an essence video. We have lots of little videos, 3 minutes long typically, which teach the essence of something. So this is the essence of the command pattern.
I find it to be elegant, versatile, and powerful. I've used it on web projects. It's used as the backbone of organizing tests in JUnit.
I'll fast forward it.
Like so. Two changes have been made. I can undo them right here by clicking this button. Undo, undo. Now what just happened there was the work that was done by little objects executing a macro command or composite command.
So you get the idea.
Undo red eye removal undoes two commands at once.
So that's giving you the essence of what that pattern's all about. Then we're getting into lots and lots and lots of examples. Our general style is I'd call it almost death by example. We want to give you lots of real-world example code so you can look at it and understand what was happening there in the design. Every page usually doesn't involve too much scrolling, so it's all right there. If you don't know what a composite is, you just put your mouse over that and learn about a composite. For example, here's a player's page, which gets into very specific design concepts of, what's the context, what's the command, what's the dispatcher for the commands, and you can look at another example, which is slightly different from the others. So we try to give you lots of, short, quick information on how to understand the pattern quickly. And then we get into some really intense quizzes. This particular quiz here, it's one page, right? But this thing could take you easily a half an hour to do because there's lots of source code here that you're going to be studying, okay? And actually, I'm in a C# version of this. We have all three languages, so some test code to study. So you'd be studying all of this code and then ultimately answering these questions here. Now, when you answer the questions, I'll just randomly answer some. You can show a hint. Okay, it says 3 out of 6 are correct. Maybe that's going to make us think a little bit deeper about, what the answer should be. Ultimately, I may hit show answers, and I get commentary on each and every one of these entries here. If I don't agree with one of them, I can post my thoughts. I can ask a question or make a comment or point out an error. So it's really meant to be two ways. We want you to be interacting with this as much as possible. So, and we usually get back to you sometimes within minutes, but usually definitely within 24 to 48 hours. Okay, so I'm going to now take us to some live stuff. I'm going to go into our refactoring album. The refactoring album has grown over the years, and the material is continually growing, but we're going to look at a particular lab. Here's a lab that we first started out with called the Automated Refactoring Lab, and it's basically talking about how important it is to use automated refactorings. So we want you to quickly learn about some refactorings that are important, like rename method, extract method. Some of these are pretty basic. There's a video to show you using these refactorings. I won't show that right now. And then there's a lab to give you experience. So here's what we're doing. We're saying there's some before code, and it looks like this. Okay, it's pretty straightforward, an employee, a programmer, and a manager. And there's some after code. Okay, we want you to get from A to B using refactorings, using as many automated refactorings as you can. Even if you're doing C++, we will watch what you're doing. Now, in the old days, for us, so 5, 6, 7 years ago, we would reflect, we'd use reflection to look at your final solution. Or in the case of C++, we would do some other fancy things to look at your final solution. So we could say, yes, you got from A to B correctly. But how did you get from A to B? What did you do? Did you sit there and hack away and have failing tests for 30 minutes and then finally get the test to pass? Or did you use some of the built-in refactoring support that's available to you? Did you run the test frequently? We wanted to know not only did you get to the final design, but how did you get there? And that's one of the things we've worked on very hard in the last year. So I'm going to show you doing this actual lab. Here's some instructions for how to do the lab, some things to keep in mind about what we'd like you to do. And here it's saying, how many people are beginner, intermediate, or advanced? I actually have examples of this. So here's one of these labs that's live on our website. And here it's showing, right, 36% are considered advanced when they take this lab, 59% are an intermediate, 4% are beginner. Okay, that's a specific lab. It's one of our hardest labs. So we like to show statistics so you can kind of get a feel for how hard something is or not. Now, I'm going to actually do one of these labs for you. So we've made it relatively easy to import things. Just to get back to the presentation, you would just download the code here on one of these pages, and we've made it ultra simple to import it into Eclipse. We also support Intellij. Right now, for the analysis we're doing, we need you to use Eclipse. We'll eventually support Intellij. So I'm going to actually do this work right now. I'm in Eclipse here, and I'm going to import an existing project into the workspace. It's going to be the automated refactoring problem in Java. Okay, there it is. So I'll close all these, and I'm going to run the tests. Okay, they're green. So, time to start doing some work. Here's the programmer class, and I happen to know that the instructions are saying to me, well, jobs done should really get renamed to be jobs completed. And jobs done count should be called jobs completed count. Okay, so I'll run the tests again. Good. Now, time to do some pull-ups. Refactor pull-up. I'm going to pull up jobs completed, jobs skipped, jobs completed count, and job skip count. Common mistake people make when they refactor is they hit the finish button too quickly. If you hit the finish button, you get to miss something important. You could be pulling up from the manager class at the very same time. These are siblings, programmer and manager. You can pull up from both at the same time. Okay? Actually, what I'll do is I won't pull up from the other one. I'll just pull up from this one for now. I'll hit finish. So it did the work. I'll run the tests. Still passing. Okay. So here's the manager class now, and it still has these methods that it really doesn't need. So I should be able to just get rid of them because it should be inheriting them. Let's make sure that's okay. Okay, it is. All right, now we see here there's a programmer class that has a perform job method and a manager class that also has a perform job method and a method called responsibilities. I want to factor out perform job. I want to move it up to the superclass. But I have almost the identical thing here, right? It's almost the same. So what I want you to do is highlight this code here and refactor extract method. I'm going to call this responsibilities. Okay, and then I'm going to take this acceptable work and I'm going to inline it. Okay, and I'll run the tests again. Good. Now I should be able to say refactor pull up. I'm going to pull up the perform job method. Okay. I'm also going to pull up responsibilities, but, and this is also not that well known, here's a little drop-down list box. That's the epitome of bad UI design, right? How would you know there's a drop-down list box here? Well, you have to know. So you click and you say, declare abstract in the destination. And I say next, I'm going to do it for manager as well, and it's going to do all this work. Okay, so I'll say finish, and it did the work, and I've got a problem. It's not happy about something. Responsibilities, I think it has to do with the visibility. Well, let me just run the tests, and of course, well, there's errors, so I got a problem. If I click here, it's going to change the visibility for me, and I'll rerun. Still have errors, so it's still unhappy about something. And it really wants this to be protected. So I could do it this way. I could just start typing, or I can use a refactoring. I can say refactor, change method signature, make this protected. Okay, and let's see if we're okay now. Still have errors. So this is a common situation you run into. Here, it doesn't know that this should be protected, so it's just gone backwards. So I'm going to have to tell it what to do by typing. Sometimes you have to type. Okay, so did I misspell it? Bill, yes, I did misspell it. Okay, let's use a rename. Okay, and I know that it should be okay now. So responsibilities is here. I have to, if you don't spell things right, you get in trouble. It's really gotten itself confused. So this thing here needs to go bye-bye. And there. I think we're okay. Overridden, okay, fine. So, well, I'm in a red bar situation here, so I've really messed up, and what I should do is backtrack at this point, right? But what I'm going to do at the moment is stop, and I'm going to run our little archiver right here, and this will generate some output for us, okay? So I can upload this right now and start to get some feedback if I want to. But what I would like to do is at least get past my compilation problems. So I will come here and make this protected. And now it's at least compiling. So at this point, let me run this test. Okay, I'm back to green. Awkward little session there, but I finally got back to green. So I'm not really doing great refactoring. In theory, if I did something and I got into a red bar situation, I would have backtracked a little sooner. Let's just see what the analysis now tells us. I'll run this again. And here's our upload. And now I'm going to upload this lab. So the next page says, go ahead and upload. And I'm going to change languages here to Java. And I will upload this. Okay, it's done the upload. On this next page, it seems I've got an 83% score. So I didn't do everything that it wanted, but I did pass numerous tests. I passed that it found the right classes, okay? It had the right inheritance hierarchy. The correct methods were on the classes, great. Sufficient testing was performed. I did run the tests. I did a rename method, a rename field and a rename method. I used the automated tools to do that. I pulled up some fields. I pulled up a method at one point. I pulled up the perform job method with that little cool technique of declaring it abstract in the destination. And I pulled up from 2 classes at once. We're actually testing to see if you know how to pull up from 2 classes at once. You can do it with the tool, so our tests are looking to see that you actually did it. Now here's a nice pretty chart which kind of shows what happened. So this is the number of refactorings on this axis and time on this axis here. And as you see, things were going along pretty well until the bar went red. And the bar was red for a pretty long time until finally it went to green over here. So this is a sort of a mediocre refactoring session. It wasn't that great, it wasn't terrible. So I got an 83%. Question? Well, it did ultimately work. It knows that it works. It won't even show this graph if you can't compile it. So the code, right, the code's now compiling and running. If I'd uploaded it prior to that, it would have rejected it and said, well, you have to give us compiling code.
So why didn't we see it go to green?
We did see it go green. It goes green right here. Do you see that edge? So right here, a little past 5 minutes, it finally goes green. Any other questions about that? Let me go to the next. Yeah.
So if you go back to the results thing?
Yes.
So are the previous lessons we got going to make sure that we know what each one of those actually means?
Yes. In the early part of the lab, we showed you a few of these techniques, okay? And we also really, I didn't go through it very slowly, but we sort of said, okay, there is a field called jobs done, and there's a field called jobs completed. It's the same thing. It's subtle duplication. Make one of them called jobs completed so they're both the same. Do that, right? So we expect you to do that with an automated refactoring because that's the best way to do it. And then at some point we expect you to pull up that duplication from the sibling classes into the superclass. And again, there's a refactoring to do that. So there's numerous tracks that came before this, right? We call them tracks because we think of these as albums. And we've taught what pull-up is, what rename is, what extract method is, and all that. So we're not trying to set you up for failure here. However, when you click the next button, here's your customized feedback. In this particular case, there were 2 particular items we wanted you to learn more about. Correct fields on classes. Your final design does not match the target after design. Employees should have only 2 fields, jobs completed and jobs skipped. Well, what happened? Well, what happened was employee has 3 fields. It has jobs. What is jobs? Jobs is let's see what jobs is. Let's say references on the project. Oh, look, there are no references. Jobs is dead code. We want you to be looking out for dead code. We give you instructions to do so in this lab, and I forgot to get rid of that dead code. So we flagged you for that. In addition, extract method performed. It's saying here that you could have performed the extract method refactoring on this code here to produce a responsibilities method. Okay, now I did do that. You saw me do that, right? The only thing is I didn't spell responsibilities right. So it's not perfect, this technology. It's only as good as it can be. So the point here is that what we're trying to do is to digitally look over your shoulder. We want to, as best as possible, look over your shoulder to see how well are you refactoring, okay? And you could argue that a big part of refactoring is knowing your tools and using your tools correctly, okay? So this is very tool-centric. It is looking to see that you did certain refactorings, okay? Other labs are a little more focused on what's the end result, and we don't necessarily know how you're going to get there. But this one is a little more specific, okay? Questions about that so far? Again, we're doing this in C++ and in Java, and the code base that is a featured part of this album is called Smellections. Okay, here's the album. Smellections is our collection of really badly written collection classes. It's the Earth's smelliest collection classes, a map, a list, a set, and you basically have to clean them up. It's a 4-part lab. Okay, and I can tell you from, okay, actually let's do this. Let's go to part 4 of this lab, and I'm going to upload some student results, okay, from around the world. So people have been using this from around the world, and we're going to see what they did. One guy in particular, I think, was pretty amazing. So let's look at this one here. This is part 4 of the Smellections lab. It's definitely by far the hardest. I've seen veteran programmers completely stumble on this lab. It involves some significant changes to the map class, and if you don't know what you're doing, very easy to get into a red bar state and stay there for a while. So this person got an 88% score. Okay, now let's look at his chart. All right, one thing you notice is our timeline is actually in hours. it can adjust to however long the lab took. Now, I don't know exactly what happened here, but he started out refactoring. These are automated refactorings. And in the close to the second hour, he did a few more. And then he must have gone to sleep or something. He went to the pub. I don't know, because I think this guy's from London. And then he decided, he woke up and did an inline method. And then he went back to sleep, I guess. And then he had this flurry of activity where he did all this stuff. And the most remarkable thing to me is he only ran the tests a little past the 15th hour. So, this was kind of startling to me. We hadn't really been looking at the data this way until recently. The graphing that we're doing is relatively new, and it's causing us to rethink our scoring, because our scoring, he got an 88% there, and to do all that work and not run the tests until well into the 16th hour, it's just, something's a little off there, I think. So that was kind of odd. Let's look at someone else's result. This was a fairly good one, and I just pick these off our site and check them out sometimes. This one had a 72% score, and he or she finished this in about a little over an hour. Had a few red bar situations, so that was a bit of an issue. But you'll notice there was never any refactoring that happened during the red bar. Right? If you see refactoring occurring during a red bar, this background color means the tests were green, then they went red, and so forth. If you see refactorings during red bar, it's usually not a good sign. Usually, I'm not going to say always, but most of the time it's better to be refactoring when the bar is green, when the tests are running perfectly. So this person did fairly well. Sufficiently green test was a test he failed, or she failed. You had numerous test failures during this lab. Okay, we found there to be too many. It doesn't mean that there were just two because you saw two red strips. There could have been several of those. It's just that's how long the bar was red. So we dinged them on that. And this scaffolding methods, this lab really requires you to create some scaffolding, extracting some methods that are there temporarily, which you then inline later on. You take the scaffolding down. And there was a bit of a problem there. So that's what other results are doing. Now, a big part of this album is not just these labs. Of course, it's learning really important techniques. And I wrote a book called Refactoring to Patterns back in 2004, and I've taken a lot of my insights from that book, things that I didn't really even fully understand yet, and I've distilled them into videos and material in this e-learning. So in many ways, this is beyond where my book was. That doesn't mean it's harder. In fact, I've found it to be easier techniques. So for example, refactoring strategies and tactics. This is a very important part of this album, teaching you what are good strategies and tactics for refactoring. We have a whole collection of them, and you walk through these and watch videos and learn about them. Here's a simple one, rejected parameter. It's one of my favorites. If you're extracting a method, sometimes that method's going to say, oh, you want to extract this method, you need 15 parameters to get passed in, or even 3 parameters to get passed in, and you don't want to do that. So you don't do that. You find a way to reject some of the parameters using some of these techniques. Okay, and there's a video that goes into 3 different examples of how to do that. Another thing to keep in mind is a refactoring rash. So one of the things to watch out for when you're refactoring is a rash. Where is the rash? Here. This is a refactoring rash. If you see a bunch of little tiny red marks all over your IDE, it usually means that you've taken too big of a refactoring step. You've got a rash. So this kid's not too happy, and you will be in a world of pain if you get into this situation. So you need to try to avoid this kind of situation. How do you do that? Well, one thing you can do is a graceful retreat. It's probably something I should have done earlier in that exercise, right? I was having trouble, and I should have gracefully retreated. A good retreat is better than a bad stand, an Irish proverb. There's also just some simple strategies. Some of them are obvious. Okay, this one you probably know. We call it a gradual cutover. A gradual cutover. Each one of these question marks is gradually being turned into an exclamation point. Okay? You want to make a change in your code to 30 different things, 20 different things, do one at a time. That's relatively simple. What's not so simple is something that I would call a parallel change or narrowed change. Let's look at one of those. If I can find it, I'll go to contents and just type it. Okay, here's our parallel change strategy. The parallel change strategy we've found to be extremely important. All this e-learning you're seeing here, we write it ourselves, by the way, and we're constantly refactoring the code as well. So we found parallel change to be hugely important. Build new behavior next to old, then gradually cut over from old to new. What you're doing is you're parallelizing all the code that you want to change with new code. It's very simple. It's very conservative. As you parallelize all of these, every place you want to make the change, you put the new code in. Let's say you used to talk to a file system in 30 places. Now you want to talk to the database in 30 places. So go to each and every one of those 30 places and put the new database code. It's still not really being utilized yet. It's just there. Once it's in place, once you've paralleled it, of course, you may recognize this as the Bay Bridge project going on here. Once you've parallelized that code, you have to then do the cutover. And hopefully you can do that cutover in small little steps, and then eventually get rid of all the old code. So that's a little technique, a little strategy for refactoring that we've found to be very valuable. Another one is narrowed change. Narrowed change says you have a bunch of places where you need to make a change. Okay, it's a few too many. Find a way to narrow them to a smaller number of places that you need to make the changes. Narrow them down to a small number, make the changes, then get rid of anything that you still don't need, like scaffolding. So narrowed change is another strategy that you can learn about. And these are meant to be used in the labs. So we teach you these strategies and tactics, and we distinguish the two. Like the rejected parameter I showed earlier is more of a tactic than a strategy. This is a strategy. It's something you can use quite a bit to do some good refactoring. All right, that's probably enough about refactoring. Let me quickly move to unit testing. Unit testing is also extremely important. And one of the things we did in unit testing was to say, how could we know if people are writing good unit tests? Okay, so this is our album on writing good unit tests. We call unit tests micro tests. They're testing micro pieces of behavior of objects, micro behaviors. So we call them micro tests. It's really synonymous with unit tests, although some people have different ideas of what a unit test is. So we're very explicit about what a micro test is. Now, there's lots and lots of background here about how to write good micro tests and what are bad micro tests. And we get into all that stuff. So there's a lot of material about what does a test look like and differences between JUnit versions. How do you design effective ones? So we're looking at things and quizzing you. Lots and lots of quizzes in here. And ultimately, of course, it leads up to a lab. So this is one of our labs on microtesting. We put you in an air traffic control situation, and we supply a class for you. So there's a class called a tail. A tail is short for an airplane. Okay, and your job is to write the code, write the tests to effectively test one of these tails. Okay, so it's kind of like a legacy code situation, but it's a little simpler. It's a single class, and you've got to cover it with tests. So we walk you through some of the issues about the tails. Tails can have different kinds of priorities in terms of how important it is for them to land, for example. And commentary from the gallery there. Ultimately, you'll download the code and you'll upload something. So I'm going to upload some student labs from this environment. Okay. Let's go to the upload page. Here it is. And I'm going to upload, these are going to be examples from Googlers who have done this. So it analyzes it and gives a score once again. Now, this is very different from refactoring, right? We're not looking at the automated refactoring you're doing here. What we're looking at is the quality of the unit tests you just wrote. Okay, so here we're saying that you did pass several of our tests. If you compare a tail to itself, does that work correctly? Do you have a decent test to test a tail to itself? Turned out they did. Comparison of identical tails, sure. Accounting for the priority class. Okay, all of these things are important tests. And there's only one test that they failed here, accounting for last contact time. They missed that somehow. Okay, so again, this is an example of us sort of digitally looking over your shoulder. Okay? All right, any questions about that? Yes?
So, like on the last one, you had two places where somebody could say whether the test was too difficult to implement or whatever. Where does that go?
Okay, let me show you that real quick. Yes? Yeah, the question was back on the page about, so right here in this lab, and by the way, this is a very fast way to navigate at the top here, so I can go straight to that how you scored page. The question was, there's two options here, right, to choose from. So it says, your tests don't account for the last contact time. In other words, this field could be altogether missing from tail, and your test wouldn't know it. Here it's just saying, I missed testing that rule, or I didn't bother, it was too hard. And if you pick one of those, you'll see how many other people were in that situation. It'll give you a percentage of who else was in the same boat. Of course, this is on my hard drive, so it's not showing the real numbers, but online it does. And then, of course, if you don't agree with that, you can put some commentary in and say why you didn't feel it was important to test that, or whatever you thought. Other questions? Okay, couple of quick things. Every page has a rate this page feature. Because we want to know if you just don't like a page, let us know. Okay, and in addition, you can say, I want to post some thoughts here and, tell us what you think of the whole page rather than just an individual part of it. So cancel that. Something's wrong with the page or something like that. So we're pretty prompt about getting back to you on that. I want to show you playlists real quick. We invented the concept of playlists. Well, we didn't invent it. It went along with the metaphor here of albums. We said, how could we give people a pathway through all this content? Because there's a lot of content here. Each one of those albums I've been showing you often takes from 4 to 6 hours to go through. So if you're in a rush or you're only interested in a specific area, for example, you might be interested in attacking legacy code. We love this album cover here. You might want to just go through this, and this is going to hit material from various albums. Okay, it's actually 6 to 10 hours of content, so that's a giant one. But some of them are smaller. I'm not showing all of the playlists up here, but so here's a playlist about design patterns that are involved with object creation. And here's one just about code smells. Okay, so we're having fun with these album covers. But my favorite by far is this one here, A Few Smells, Patterns, and Refactorings. Is a nice blend of different content from about 6 different albums, okay? And, you just go through it and learn some things. So the playlists, eventually you'll have your own ability to make your own playlists. For now, it's just something we're providing. All right, I think it's time for me to show you some test-driven development and the new stuff we're doing there. This is the very newest thing we're doing. I'll come down here to the Java version of this album. And as usual, we spend a lot of time teaching test-driven development before you ever get to a lab. So there's all kinds of activities and videos. I'll show you an example. Here's our assert first video. At one point, we made all of our videos captioned for the hearing impaired. So it's also good for people that don't speak English as their first language. And you can click here to go full screen.
Here we want to test that we can get back an open-close tag for our quiz. So we're going to make up an object. XML builder will be the name of that object. It doesn't exist yet. We're going to make up a method, toXML. toXML will be the method we call to get back the XML. We have just done assert first programming. We run the test. It doesn't even compile. Of course it doesn't compile. There's no class associated with XML Builder, and certainly no method to XML. That's okay. We're designing what we need in the test by doing an assert statement first. This is a great way to organize your thoughts about what you actually need to test. You're sort of working backwards, just like we work backwards when we do test-driven development.
So lots of these videos that guide you through things here, and ultimately you get to some labs. So what I'm going to show you now is a new lab. It's not even public yet. This is very, very new for us. It's about a spreadsheet. We want you to test drive basically an interpreter that's going to be able to interpret little formulas, okay, very simple formulas. So here's
Ever used the spreadsheet? We thought so. Here's a vintage spreadsheet app.
So Brian's going to walk through what we want you to do. There's a formula. It's doing some evaluation. Here's ultimately what the composite is going to look like, and we want you to test drive that. Great. So we go through some more background material, what it should look like or what we think it should look like. Say you're going to do a test first, and ultimately you download some code and get started. So I'm going to do that real fast. I'll just directly import it in. We always supply some kind of starting example, so it makes it easier for you. So you don't have to create a whole project from scratch. Okay, so there's the interpreter spreadsheet. And I'm going to go here into an existing test we created. I'm actually going to rename this just to be called constant. And I'm going to test drive this code. I'm going to say assert equals let's say 42.0 constant dot evaluate. So there I am doing assert first. Hit Control 1, create the local variable. We'll give it a type called constant expression, and it will be equal to a new constant expression. I will create this in the source folder and make the evaluate method on it and import this assert equals and run. And I got my first failure. Of course, it's expecting 42, but it got back null. Okay. So test first would say, well, what's the simplest thing that I could do to make this pass? Well, I could just return 42.0. This is where some people say, what are you, crazy? But this is this do the simplest thing that could possibly work concept. Still failing. Well, what happened here? Oh, we might have a little precision issue. I'm going to use a precision argument here that existed already, and we're at green. Okay. Pretty good. Now, I can do things in here that the analysis is going to say not very good. For example, here's another test. I'll test summing. Can I sum two numbers? Assert equals, and I'll say 50, and I'll say sum dot evaluate. Okay. And let's just create this thing, and I'll just say equals new constant expression, right? And that will, of course, fail because it's not at all what we want. So we're in a failure situation right now. What if I start refactoring during this failure? I'm going to say, for example, let me go to the constant expression, and I'm going to refactor, and I'm going to extract an interface. I'm going to call it expression. Okay. So it made expression, and it made constant expression implement that interface. Okay, that's pretty good. If I run the test, well, I'm still in a failure mode here. So Okay, let's actually make this actually pass. Instead of saying constant expression, I'm going to say some expression, which doesn't yet exist, and I'm going to say new constant expression 48.0 and new okay. And this entire constructor, this entire class doesn't exist. Let's create the class in the source. Good. Let's create the constructor. Here I will tell it that I want this to be an expression called the augend. Here I want it to be an expression called the addend. Good. Save that. And at least we're compiling now, right? What doesn't it like here?
You have to find that constant constructor.
Oh yeah, I never did close the, well, I closed that. Can you say that again?
The constructor and the constant expression doesn't exist. It's still hard coded to 42.
Correct, right. Okay, so let's look at our constant expression and say we need something that's going to take a value. So 42.0 is really what we want. Let's create that. Good. So I'm going to give it a name, constant, and I'll assign it to a new field. Okay, and I'll have this return that constant. Okay, so let's delete some of this unnecessary stuff. And still red, but we're getting closer. Now, I'm intentionally doing bad TDD here because I want you to see the analysis that shows up when we don't do good TDD. But at least at this point, we're compiling. So let's go back to the sum expression and say, okay, well, we obviously have to save these things. So I'll assign them to new parameters and assign this to a new parameter. And we will return the augend dot evaluate plus the addend dot evaluate. And rerun the tests. Still green, still red, sorry. Now what dumb thing have I done now?
Constant expression.
Precision.
So we got constant expressions here. First of all, these should be expressions. They shouldn't be constant expressions. They don't need to be. Later on, that would hurt us. So I'll do this. And of course, I could have done that in an automated way, but I didn't. But that's still not going to do it. So we need a precision. Okay, precision. Now we think we should have a green bar. Okay, we're at green. Let's see what the analysis shows us about that session. Again, I will run this little archiver. And we just wrote a plugin that's going to do this instead of having you run that little program. But I won't show that today. And let's upload that. Take a look. Okay, it did the analysis. And right now we're just jumping straight to a diagram. Let's understand what happened here. So point number one was we started with a failing test. So we did do that nicely. TDD wants you to start with a failing test. And so we're at a score of 1, a TDD score of 1. We went up to 2 here when we made the test pass. Okay? And that's when the bar went green. And then at point 3, we again started with another failing test, right? The first one was, it says it here, it's the constant test. This is the second one up here was this sum test. But then we did something that we considered bad. That's why the graph went down. You refactored while the tests were red. Okay? And there were several little refactorings we did, but this shows up here. This is the bad thing to do. You just don't want to refactor when the tests are red. It's not a good idea. Better to get to green before refactoring. But we did eventually get things going. It took us a while. Look how long it took us to finally get to green. So this is point 5 where we got to green, and finally we were done. And that shows this particular TDD session. In the future, we want you to be able to see lots of these graphs, compare them to experts, get even more feedback from us in the graph about how well you did, so you can kind of help yourself learn. We would use this technology in in-person classes or online. So there's actually, for us, there's very little difference between the in-person experience and the online experience. We're trying to make the e-learning so good that we'd be crazy not to use it even when we teach in person. The only big difference is we can't see your facial expressions while you're doing this stuff, but of course you can interact with us online. So basically, that was kind of a whirlwind tour of a bunch of things in our e-learning. There's lots and lots of content to go through. I've just shown you just the tip of the iceberg. And Google has licensed all this from us, so you have access to it. I have this here. If you're internal at Google, you can go to go/ILElearning is a site that has tons of information. In fact, Amanda has rolled this around the world. And it's actually, I think we rolled it out worldwide. We had almost 0 questions about how to do it. People just followed the instructions and got their albums and started studying, and there were no issues. So if you have any questions, you can email ngdu-training@google.com. Yeah?
When's the expected release date of the Intellij Plugins?
We are working on those. I would say it's probably at least 1 quarter away, so about 3 months away, 2 to 3 months away. The question, yes, sorry, great. When are the Intellij plugins coming? So it's about 3 months away that we're working on that. So we do definitely want to support Intellij. The data, much of this data was just a little bit easier to gather in Eclipse, but it's totally possible to get it in Intellij, so that will be there. Any other questions? Yes?
I noticed you were doing most of the examples here in Java.
Yes.
And I know that automated refactoring tools in C++ tend to be more primitive than Java. Is everything that you do in Java actually supported in C++ environment?
Yeah, so the question is, I was showing most of the things in Java, and can we do this in C++? The answer is, we have all the labs I showed you today are all available in C++. In fact, I'll bring one in right now real fast. The only difference is you don't have as many of the refactoring tools available to you. You have some. You have rename method in the CDT. So I'll take, for example, the automated refactoring lab we looked at earlier in C++. Here it is. Okay, so here's this thing. It compiles it. In fact, we've even written a little plugin to Eclipse to allow you to see a green bar. So I'll run that for you real fast. And the only major difference, so if I say run as gtest, it ran, and here are the gtest results. Okay, green bar. So you'll get a green bar, red bar, and you can go to the source. You can do a rename method, or rename right here. I can say refactor rename. That totally works. So, it's not as full-featured as the Java by far, but you can do a fair amount with it. And we've instrumented gtest so that we're picking up a lot of this metadata to do the analysis. So we're doing our very, very best to support it as much as we support Java.
Does it affect the evaluation at the end, where you couldn't tell as easily whether somebody was doing an automated refactoring method because they had to do it manually?
Okay, that's a great question. So yes, the question is, does it affect the analysis at the end? We are inferring refactorings by looking at snapshots of your code as you work for C++. So if you don't use an automated refactoring to do something like a pull-up, you're pulling up from 2 subclasses into a super, we will look at the differences in the code and say, yep, they effectively did a pull-up. So you get credit. So the answer is yes, we do account for even manual refactorings. Any other questions? Yes?
For the TDD graph, is that data that you could get when I'm doing my own TDD, or is it taking advantage of the knowledge that you're building working on this expressions lab?
The TDD graph is really pretty generic. I mean, it's doing it for for that particular lab, but it could be for anything you're doing. There's a little bit of metadata stuff that's set up that we expect there. We're trying to make that go away as well. So with a simple plugin, that data will be available. But that TDD stuff is pretty early on. We have, you know, I'd say at least another month of work to do to get that out, because it's pretty easy to trick it. I didn't show you that, but you can trick it pretty easily. You can be in a test and write assert 1 equals 1 or 1 equals 0, and it's a failing test. You can go and write some production code and it says hello world, and then you can go back to the test and say, you know, assert 1 equals 1, and it looks like you went from red to production to green when you didn't do TDD at all. So we're actively looking at ways to make it really, really industrial strength and focus on not letting you, like really seeing if you are truly doing test-driven development. That's why it's not out yet. But you know, ultimately, we'd love it if you could use it on any project, not just our labs, if that's what your question was. Yeah. Okay, well, thank you very much for coming today.